Okay, hello and welcome. Here we are another day. Gonna work on another algorithms question. Let me see if I can just give it a moment to get the audio. Algorithms question. Okay, audio is working. Let me pop out the chat. Okay, deep breath. All right. So a few things that I wanted to say before I begin. I think I'm good to go here. Yeah, I think we're good. All right. Yes, very good. So, K-Concatenation maximum sum. Pretty low acceptance rate. We'll come back to that in a moment. What I wanted to say before I began is actually I found something online. It's more like I found Mr. Cloudsy. Shout out to Mr. Cloudsy. He's got, does a good job, and I appreciate his work. I've been watching some of his videos lately, and I kind of was like, wow, this is, some of the stuff is very good. and I laugh at some of the videos. So I appreciate that. One of the things I saw him, so that you have an idea of like where this is coming from. So it's from he used this Excalidraw, and I thought that was a cool name, and I also appreciated the style of this. Like, so shout out to Excalidraw and whoever made that. This is like really useful, I think, tool for like the kind of stuff that I do. For sure. Like if I want to just if I just want to draw like like the other day I was talking about functions and I was drawing it on paper, but I could have been like f of 1 of x is equal to a plus b minus x, and then that way I could do what I would be doing by hand on a piece of paper. I could do it on this. I like this very well. Very good. This is great. I was kind of looking for something like this too on Arch, but I don't I was thinking about using GIMP, but it like takes too long to load GIMP. Quite frankly, it's not that simple to just pull something up and just start drawing and writing. Like I really want something that's like this. I could just 1, 2, 3 get going and start drawing things. So I might start doing that in the future, right? And I had like the f1 of 2 going on the other day as well, and like I can actually just draw the stuff instead of just trying to orally explain. It's just instead of just speaking and letting the viewer have to try to follow that, right? Like it's obviously way too hard to follow and requires too much attention, all that. Like I don't expect people to follow those things, but at least there's like a chance that people could follow some of the more math-related things. If I decide to do that. So yeah, I think this is good. This is good. I like this. It's good. Excalidraw. Yeah, I'm pretty excited about this actually. I'm like, this is cool. Obviously, I drew a little. This is how I feel right now. This is in my mind. This is how I'm feeling. Just on my adventure here with a new with a boat. The new boat. All right. So yeah. Anyway, Excalidraw is pretty cool. And shout out to Cloudsy. Appreciate his work. I actually thought about making a video in response to some of the things he was saying. He was talking about things in talking about things that you'll experience in employment, and I kind of wanted to comment on some of those things, just because. Is that what it was? No, I forgot. There were like things. Basically, there's just stuff that he talks about that I can relate to, and I can talk about also. Add my own comments. And some of the things he did also, I think, are very. Some of the things are just really funny, and some of the other things are have been very helpful for me, actually, personally. Like I have a tendency to really focus on certain things and miss other things that are important, and it helps a lot to have other people kind of explain those things. So yeah, just want to say those things, I guess. Anyway, just so now it's not like, oh, where did this tool come from? It's like, well, I was watching this guy use it, and I was like, I like that tool. I like that. Also, another thing, like I really appreciate free software. Like I have to like really emphasize how much I appreciate free software. This is like a really good example. It's like I don't have the time to build something like this myself. It's like if I could just find one on the internet somewhere and use it, like that would be great. And yeah, I like it. It's good. All right, anyway, moving on. So K-Concatenation maximum sum, a lot of votes, pretty good number of submissions, very low acceptance rate. Everybody got destroyed by this one. We'll see how I do here on this. Let's give it a shot. Integer array, an integer k, modify the array by repeating it k times. For example, if array 1, 2 and k is 3, then the modified array will be 1, 2, 1, 2, 1, 2. Return the maximum subarray sum in the modified array. Whew. Oh boy. Note that the length of the subarray can be 0 and its sum in that case is 0. And as the answer can be very large, return the answer modulo 1,000,000,007. So this is, I like this question. So there's another subarray sum variant. Obviously, we've seen quite a few of those already. Significant number of those. So here we got 9. We just add the whole thing straight across. Here we get 2. The best we can do is add 1 and 1. And then to the left and to the right of that, we can't really exactly cross that boundary. And then -1, -2 for 7 is just 0. Okay, interesting. And the array could be 100,000 and k could be 100,000. So 100,000, and the elements can be 10 to the 4th. So the number could be very large. It could be 10 to the 4th times 10 to the 5th times 10 to the 5th, which is 5 plus 5 is 10 plus 4, 14. It could be 10 to the 14th is the largest number it could be. However, I think these are pretty good example cases because it kind of indicates that, like, basically, if the array is, if the largest subarray sum goes all the way across the array, then it's advantageous. Well, it's a little more complicated than that, but let's just say one idea, if it's all positive, then the whole array will be used every time, and then every copy of that is going to also be included in the subarray sum. And so you just basically take the sum of the array, modulo 1,000,009, and then multiply that by the number of times it's repeated by k. So it's going to be possibly 10 to the 9th. So the sum doesn't have to be modulo 1,000,009 because the sum is at most going to be 1 billion. And then you take that and multiply by k in that instance, right? That's very straightforward. But you get some insight here with the next example where if you put 2 next to each other, you realize that, hey, there's like a boundary across the subarray sum where you're not going to add across -2 on the left side nor -2 on the right side if you're looking at 1, -2, 1, 1, -2, 1. And it dawns on me that because of that, adding more values to the right doesn't actually improve my score. So I only need to consider the case when k equals 2 in that scenario, right? And I think probably you could say you probably don't need to calculate very much here. You probably could just do like k is, maybe 1, 2, or 3. You probably only need to go to like 2 or 3, really. When k is 3, if you run Cadenes on k is 3, maybe the easiest thing to do is go k is 2 and k is 3 and take the difference between the two. And I would argue that as you add more values, right, as you add more copies, like if your result didn't improve from k equals 2 to k equals 3, then adding more is not going to improve the result, and you can return immediately, right? You're done. If the result does improve from k equals 2 to k equals 3, because here in this case it improved from k equals 1 to k equals 2, but that's kind of like, I guess the same improvement should occur again if it's possible when you go into k equals 3. If you can improve from k equals 2 to k equals 3, then I think you could argue you could repeat that all the way to the actual value of k. We'll call it j. We'll say j, so scala draw, right? I can actually here, we'll delete our picture. So k equals 1. So you've got is this? 1, -2, 1, -2, 1, 1, -2, 1. Yeah, so here I can actually draw the things I'm talking about. So here you can see, you get, here you can see, you get your boundary, right? You get your, this is the maximum subarray sum. But if you added another piece here, added more, 1, -2, 1, doesn't actually improve, right? You just get a repeat of what you already had. Or okay, like that. Yeah, you just get a repeat of what you already had, right? And I think what you could argue is that if you go from k equals 2, which is this case, this is k equals 2, or let's do j is 2. Let's do j equals 2. Let's do large, extra large. Draw very large font. Can you see this? Or is my face in the way? Oh, okay. Camera's kind of, I have to be cognizant of where the camera is. Yeah, j equals 2. And then this one is, what hotkey is it? A? I like this a lot, actually. As you know, as you can see, T. J equals 3, right? So now you can hopefully understand what I'm describing here. And you can see how this doesn't change as you add more pieces, right? If I went to j equals 4, it should be clear that you're just going to keep getting a repeat, right? However, this is not always true. Like in this case, obviously, if it's positive, you add more pieces, you just keep adding them, right? You just multiply straight across. But it gets a little more complicated, I'm sure, where you could do something like 1, 2, -2, 1, or something where, well, I guess this is it, right? Where you can go to the right and to the left and come across from right to left, right? And you merging those pieces is actually more beneficial than not. And if it was advantageous to cross the midpoint, if it was advantageous to cross a midpoint, then it would always be that advantageous. It would be advantageous in the first instance, and it would be advantageous for every copied instance afterwards. Therefore, even if, so I guess my question is, like, what about a case where this midpoint, overcoming it is, no. So if it was advantageous to overcome the midpoint by going right to left, right, from right to left, if it was advantageous to overcome that midpoint and connect those spots in one instance, then it will be advantageous in all of the other copies as you go. And conversely, if it's not advantageous in the first instance to cross from here to to there, then it won't be when you start combining, right? So I think basically the options are just analyze k equals 2, or note that the subarray sum is the entire array, and then you just multiply by k. Yeah, I think that's the case. I'm trying to think if there's a better way to do this, different way to do this. Yeah, you don't need to look at 3, k equals 3, because as mentioned, if you cross that boundary, it's necessary to cross that boundary to have anything more than k equals 2 be relevant, right? Anything more than k equals 2 is not going to improve the score unless you cross that boundary. That's what I'm trying to argue here, and I think it's true. I'm gonna go with that. Let's do okay. So first things first, let me perform Kadanes and check to see if it's equivalent to the sum. If Cadenes is equivalent to the sum, then it's a matter of just multiplying by k. If Cadenes is not equivalent to the sum, then I want to go to k equals 2 and perform Cadenes on that. And I think if it's not equivalent to the sum, then k equals 2 should be the maximum that I have to consider. Yeah, I think that's it. And this is assuming k is greater than or equal to 2, by the way. If k is just 1, then obviously it's just Cadenes. K is 1, it's just Cadenes. If a k is 2 or more, then either it's going to be equivalent to just multiplying the Cadenes result of 1 by k, which is the whole thing, or it's going to be the Cadenes result on k equals 2. And that's all I have to consider. So there's a few things here, but I think it should be linear time overall. Linear time overall. That's, I think, correct. I think that's the right way to go. So we can run Cadenes first, one iteration. Cadene. We'll write a subroutine here. Const vector int v, and we're just going to say const int x and v, int current best, return best. Current is going to be maximum of x and current plus x, and then best is going to be maximum of best and current and best, or best and current. Very straightforward, Cadenes. So it was sort of kind of straightforward. So that's Cadenes. Let's get the constant total is going to be accumulate array begin, array end, 0. Okay, constant subarray sum, or k1, Cadene of array. Then we're going to say if total equals k1, then we're going to return the total times, so a long, convert this to a long, right? Then take the total times k and take that modulo constant mod is 1,000,000,007, right? Modulo mod. And yeah, and then we just say if k is 1, return k1, right? Now we're assuming k is greater than 1. So if the total is equal to k1, then that means the whole array is what we're going to copy over and over. That's just return this as mentioned. And then otherwise, we're going to take a standard vector int of array 2. We'll say array 2. And size is going to be array.size, bit shifted by 2. I want to copy into this array twice. Size 0. Let's do copy. Let's do it this way. Just copy array 1 twice. I might need to do it this way. Yeah, that might be better. Okay, and then just run Cadene on that second array. Something like this. Something like this. I don't really know exactly, but I'm assuming something along these lines works. All right, it works in these cases. Let's generate some test cases. Let's write a quick script to do that. So awk script begin. Oops, whoa, what that? How are we doing with various things here? 20 minutes in? Okay. First things first, let's do date plus %s %n, get line, seed, srand seed, print rand, make sure that's working. It's working. Okay, next we're gonna run a so k is gonna be let's do that boundary k. Well, let's do n is going to be the number. I'm going to find n. I'm going to find k. We'll do different constants. So constant 1 will be k is going to be between 1 and 100,000. Let's do like 100. Is probably fine. Constant 1 is 100. N will probably do also 100. And then we'll do n is going to be between 1 and c1. We'll do c1 for n, and the other one k is going to be c2. Right, something like this, and then I have a for loop and print. I have an x value for all the values that I want. Print x and print k, so x and then k. And actually, it's going to be C1, C2, and then there's actually C3 and C4. C3 and C4. These aren't like great names for constants. So 201 and -100 I think are good. Come back to that. So I is 0, I is less than n, increment I, go for if I is greater than 0, then do such and such a thing, otherwise get a new value. It's going to be C3 plus rand C4. That's the idea. Yeah, this is maybe a little awkward the way I'm doing this. I is greater than 0. We're going to say x is, we're going to put, I always get confused. Does it go before or after? Well, I think the comma goes after the x, because now I'm going to add a new value afterwards. There we go. Okay, nice. And I'm going to print the x with these surrounding it. All right, now I can just say sequence j in, and I use a j just because I tend to use I. Because I tend to use I in my, oh, I think also this has to be at least a 1, the k. Yeah, wait, how did I get a 0 for k before? Did I get a 0 before? I saw a 0 there. Oh, okay, maybe I was seeing things. All right, never mind. Okay, there we go. I think that's what we want. What I want. Let's do another one. Just do a few tests. Make sure I've got the right idea. Wrong answer, of course. Okay, so I have the wrong idea. No kidding. So what happens in this case? Let me see. So when this is 2, should get it right. But when it's 3, it's wrong. 4, really. Okay. So I was supposed to add another 864. Interesting. Right. Okay, so my reasoning was not quite right. It's a good thing I tested it. I kind of thought it wouldn't be right. Like this, I didn't prove it. I just kind of thought, I think it makes sense, just if you don't cross this boundary. But how does this work? Where it's suddenly worthwhile to add more What is the largest subarray sum for this? Is it the whole thing? Do you have to put the whole thing together? Because that's not 968. 968. Okay. What's the total? So I don't actually know. I'm missing something important that I don't see. Interesting. Interesting. 20 minutes? Okay. This might be a while. Okay, so my total is 864, but K1 is 968. Oh. I think if the total is positive, then I can add the total. Oh, I think that's what's happening. If I go to K equals 2. Okay, interesting. Maybe that's the issue. 864 plus 968, I think it's 1832, right? No, it's not. No, it's not. No, it is. No, wait. Yes, it is. Yeah, 1768 plus 64 is then 1838 plus 4, or 28, 1828 plus 4, and then that's 1832. Yeah. Oh, okay. Oh, so I think it's a little more complicated than that. I think it's it could be. If the total is positive, that's what it is. Oh, if the total is positive, then greater than 0, then I want to take more than array size, just cadenes of 2. That's what it is. I don't think it's got to be equal to K1. I think it just has to be greater than or equal to 0. Greater than 0. Then you want to take, now actually, there's another issue here where probably if the total is greater than 0, I think a better thing to do would be to take the cadenes of size 2 and then add this total times k minus 2. I think that's better. And the reason, no, actually gets a little more complicated than that. No, not quite right. Okay. Okay, yes. It's something like that, yes. Cadenes of size 2, if total is greater than 0, represents going from left to right and then right to left, right? Basically the endpoints, connecting them together. And then also, if k is greater than 2, plugging in a bunch of these things in between each time, going all the way straight across each time. I think that's correct. Also a little more involved, a little more a little complicated. Yeah, let's do that. So if k is 1, then we return k1. Otherwise, we're going to say if total is greater than 0, result excuse me. So take this k minus 2 times the total, make it a long, take this modulo, and then add this to result, and then this should be, this also should be mod, I think. Yeah, that could end up being over 1,000,000,007. And then something like this. Something like this. I think, I suspect. I don't have a proof that this is correct. But I think this works. Let's do a much larger value of k. How are we doing on time? 31 minutes. Okay, looks like I got the right idea. Let's try some more test cases. I didn't really have the right idea before. I've got a variation of that idea. Let's do 3 of these as they are, assuming that they're all correct. Okay. Overdid it, overshot that one. Okay. Yep, looks like I have, I think this is the right idea. Let me try now with tweak these constants a little bit. Let's make it more negative. Make this more like 150. It's usually negative. It's a little more complicated. Let's do that a couple times. Okay. Looks like we're fine. A couple more times. Let's do more numbers, make them tighter. So n is C1, so more numbers, and C2, let's make them like pretty small. K, oh no, K could still be like 100. Yeah, K could still be larger. Let's make these smaller, this range smaller. The range is like 5, and the numbers are gonna be like -2. So -2 plus a random number from 0 to 4 puts me at like, yeah, -2 to 2, something like this. Do a couple of these. And then I'll increase the range a little bit more. These may run into some issues. Things I didn't realize. Things I didn't see. Oh, those are fairly reasonable. Let's try again with a few more, a little bit of a greater range. Yeah. Okay. This looks pretty good. I think I probably would have caught something by now if there was something glaringly obvious. I'll do one more of these, I think, and then that'll be probably enough. Just in case there's somehow the logic is not quite right, I don't realize it, because it's sometimes hard to catch that, you know. I think I have the right idea, but it can be challenging sometimes. All right, let me go for it. So yeah, there we go. Looks like I have the right idea. I'm gonna go just run it one more time. Anytime you change the code, you probably want to run your test again, even if it is just a comment. Well, there could be something I'm missing. Oh, how did I do? Got it. Sweet. Yep. That's linear time. Pretty good. So let me submit it a few more times just to see the test cases, and then it's not the fastest. It could be faster. Probably faster would be to inline cadence. I could inline here. It's also yeah, recreating the array again is a little bit awkward. Building the array a second time, getting all that memory. I don't know if there's a way to call cadenes like twice on the array. I mean, I guess I could do double cadenes. That's like another idea. Let me submit it a couple more times. Show you that. Show you what that might look like. Okay, yeah, it's reasonable. Let me try to optimize this a little bit. Okay, so I'll show you what that might look like to optimize. 1, 2, 1, 2, 3. Submit it one more time. Cool. So yeah, that's my. So what I can do is inline cadenes here. Do this once. Current best, right? K1 is then equal to best, right? Modulo mod. And then I can run this again over here and save a little bit of effort. So instead of running this a second time, right? I can take current and best as they are and just run through it again as if we were just going left to right and then left to right again. And that have this result is going to be equal to best modulo mod. So the problem with this is I probably want, let's make these longs. I think it's easier if I do it this way. I think it's easier if I do it like this. And right, because now it could be over 1 billion. This may be redundant, but I think it's fine to have that there. And same thing here. This might be redundant as well. Now, if the total is greater than 0, now I can update the result this way as well. Yeah, a little bit confusing as to what's going on here, but it's kind of just it's a inlining of the previous code and then an optimization based off of that. Convert these to longs, maybe. I mean, they're gonna have to convert them to longs anyway. It's a little bit slower because of this, because I'm using longs. Just easier to think about it if you use longs. If I use longs, I'm gonna submit it and go for it. Could be wrong. No, I think it's still right. Yeah, there we go. So okay, not much of an improvement actually. I thought maybe it would be a little bit faster, but not really. So it saves the extra memory, right? I don't need to use the extra memory now. I don't know if I need this total. Oh no, I still use the total. Yes, I do a few passes. Actually, it's like 3 passes. Don't think I need the total unless down here. Yeah. So let's see. Okay. Yeah, better on the memory. Usually improving memory is good. It's something you kind of want to do. So improves the memory bit. Let me submit it one more time. So 88% is okay. Not crazy, but it's okay. Let's try one more. I'm trying to think if there's like a better way to improve this. I mean, this is okay. This is reasonable. There may be a better way to do this as well, even better than this. This is pretty good though. This is basically 1 pass, and then a second pass when k is greater than 2, and then a third pass. It's like 3 passes through the array. The thing that really slows this down is the converting to back and forth between longs. That's kind of, oh, there we go, 98%. Pretty good. Nice. I think if I thought about this a little bit more and didn't convert back and forth between longs, then this would be even better. But I don't think I actually need to convert between longs. It's probably best to do that. I don't actually need to, no. No, I don't. This result this result will fit an integer based off of the numbers they gave me. I don't need to use longs here. It's just that these are longs. They don't need to be longs. Yeah. That's confusing. Yeah, because 10 to the 4th times 10 to the 5th times 2 is 2 billion fits in an integer. These are never going to be too large to fit an integer, the current and the best values. The result should fit as well. The total should fit as well. The only thing that might not fit is this. This calculation you should use a long. There's only one operation, so it shouldn't be a problem to convert to a long. And I think this is also correct. I'm gonna go for it. See if it's right. Okay, very good. But yeah, I did get the 98% a moment ago. Let me see if I can submit this a couple more times, see if I get a better result. 1, 2, 3, 4, 5. Yeah, it uses even less memory now. Even less memory. Getting closer and closer to that 100% for the memory and the runtime. 1, 2, 3, 4, 5. Okay. I want to go ahead. Yep, there we go. Very close. Very close to 100%. I think if I kept running it, maybe a little more optimization could be done. And then we can go for 100%. But that's pretty good. That's pretty good. 99.69%, very close to 100%. Thank you for watching. If you liked the video, give it a like and subscribe for more. I'm going to restart the stream on another question. Just keep going. About 50 questions I want to get through. I don't know how long it's going to take me, but I'll just keep going. I'll just keep going. So yeah, thank you for watching.